Hello, participants and hackers. How are you this fine evening? I can see a lot of people joining us from different places. Green Planet says he's from Noob Entity Team and away from Ahmedabad. Hi, Kushal. Hi, Shesav. Hi, Rohan. Everybody. I hope you all are really excited. Can I get a yes in the chat if you are super excited for our first workshop today? Just waiting for a couple yeses in the chat. Awesome. We can see quite a few people here. Amazing. All right. So I am Pooja Kira, and on behalf of the entire Hack This Fall 3.0 team, I welcome you all to the first workshop of our five-part series where we assure you that we will upgrade your skills and teach you with the intricacies of all things technologies. Today, we have with us Mr. Ghan Vashisht, co founder and CTO of Zeeve, who will be walking us through a very crucial topic Web3 infrastructure automation using Zeeve. Sounds complex? Well, he'll make it very simple for you. I urge all the participants to please grab a pen and a paper because today is going to be a blast of information and we want you all to grasp that. Oh, and of course, how can we not give surprises? Tweet about this live stream on socials by tagging us at the rate hack this fall and using the hashtag hack this fall, and we will randomly select a winner and send them swags. Sounds good? Awesome. Without any further ado, let's bring up Ghan over here.
Hey everyone,
Hi
don't
Ghan,
go
how are
by
you?
my hair. Yeah, I'm doing absolutely fantastic. Don't go by my hair. I don't do guitar or drums. I do Web3.
I was going to ask you that, but since you already cleared that out for us. So, before we actually dive into the session, I would really request you to introduce yourself to the folks who are seeing you for the first time.
Yeah, so like you said, there is a lot I've done, not as critical as a lot of folks here might have been doing already. So I started my career about like 15 years ago in technology. I started with telecom, then moved into defense and aerospace, did some game-changing weapon tech, and then after that I moved into media and broadcasting. So I was very fortunate to become part of two of those transitions of technology I've seen. One, when I was in telecom, I've seen from twisted pair to VoIP, and when I got into media and broadcasting, I saw how RF is now being transformed into digital VoIP, or you can say internet TV. I saw both. And then Web3 caught me because I could not resist knowing so many industries in different ways and could not stop visualizing how different use cases could have been made possible and were not made possible, but this technology can really do it. So this is how I transitioned into Web3, and there is a lot which happened in just a very little time. And I think I'll definitely share some bits and bytes here and there during the conversation today.
Awesome. Really looking forward to it myself as well. And I can actually see that you come with the humongous experience working with cutting edge technology since the beginning. So, I give the stage to you and let's hear it from you.
Yeah, thank you very much, and thank you everyone for joining in. I'll try to make the day best for you today. Let me share my screen and let's get started. So, so the topic of the day is importance of Web3 automation, and specifically around infrastructure and what it means, what people do about it, and how do they see it, and what you can do with it, and how do you utilize the infrastructure automation, and of course from the definition to the execution and the utilization of it. So we'll talk about almost everything. Of course, we know that the audience is pretty much all Web3, but still we would do a quick run around what is happening in the industry, what is happening in the Web3 space, what Web3 is itself. And if you do a quick retrospection of the technology's existence, then you would realize that in 2018 nothing much was happening. But then 2019, when pilots and POCs were trying to get matured a little bit. Now in 2023, when we sit specifically at the after the completion of year 2022, enterprise blockchain specifically and a lot of other implementation have established themselves in a bigger way. And if you go by these studies and surveys, which not just Deloitte but a lot of research firms are doing out there, you would see that more than 55%, implementations across the globe in all the big logos which are getting into the production stage. So the days of pilots and POCs are gone, and we are now seeing a lot of implementations coming into production. In fact, it is not just taking strategic priority in these organizations. It is in fact taking a tremendous value add curve in terms of how do they see it now. So there was a time when they used to shy away from it, but now they pretty much look up to it as a technology which can change things for them. So apart from general facts and numbers, you can read them, of course. We would do a quick read on for the sake of the audience itself, that what is Web3. I'll give you some versions of mine as well. You would have read so many versions of yours, but I have my own version, and I have a not just a version but a vision. How do I see it in future? So I'll talk about that here. So this is pretty much what everybody has told us, that Web 1.0 was read only, you talking to the internet websites and all, reading the content. 2.0 was interactive, you writing, reading both, and 3 was like simply decentralizing these operations. But I see it slightly differently. I see it from the computer networking perspective. It's a different opinion. It may be right or wrong, but I'm going to share it anyways. So if you go back in time when there was nothing by the name of computer networks, because there was only one device. You can imagine one human. What would one human do on planet Earth but scare from mosquitoes alone? So there was no need of communication at all, hence no networking required. But then they invented another device, or you can imagine another human being came upon planet Earth. then they then they decided that, oh, these two devices, they need to communicate. So this was the first peer-to-peer implementation they have done, a network where two devices are there and they're talking to each other directly. There was nothing in between, no centralized party. Then came the third device. They still realized that they, ABC could talk to each other, so they decided to connect them with each other directly, so they could talk to each other. That's when the topologies would started existing. Now the fourth, the fifth, the 10th, the 20th device, and it got complicated. You know why? Because you do not want 20 devices to communicate to each other just like that all the time directly, because you're increasing the overheads. So they decided, and now's the time we move on to a newer topology. They said, like, okay, we would put a central device. All the people can send the messages there, and this device would pass it on to the others or the relevant ones. That's when the typical client server computing actually started. So if you see, we started with peer-to-peer computing, where centralization was not there. It never existed in the first place. But then, because of the infrastructure limitations, or the way network evolved, we had to put in the centralized party in between. But what happened beyond that? So today's Ethereum, today's Bitcoin, today's Avalanche, today's Polkadot network, I call them semi-decentralized. I don't call them decentralized already. Reason being, just look at the numbers here. In the centralized systems, there was one server taking care of multiple devices, thousands of devices, or maybe hundred thousands of devices, or maybe millions of devices. I'm not taking into account the redundant servers, the clusters of them and all, because they all had one purpose: node balancing and redundancy, disaster recovery. So I'm not taking into account those as multiple servers. But I'm saying that in the client server model, one server was responsible, one machine was responsible, or you can say one node was responsible in that sense, to cater to all the users on the other side. If you see Ethereum network of the date, you would find similarities and some dissimilarities. Similarity is that there are 8,000 to 10,000 servers or nodes serving to millions of wallets or users. This is the similarity. So we still are in a model where some servers are running for so many other users. It's not peer to peer, of course, and this is the reason why, because always and all the time you have to submit your request to one of the nodes. You cannot do everything using your app or phone or web, right? You have to submit the transaction to the node, and that chain of nodes would in the end decide for whatever happens on the network. So you can say that instead of one centralized server, now there are 8,000 semi decentralized set of servers owned by different parties are running this client server model in one way or other. What happens next if you continue to decentralize it? Because people usually talk about the level of decentralization. They say like we have to decentralize it enough, more than enough possible. Until that point we would not stop. Decentralization is the core of the blockchain world, so let's continue to decentralize it further. Now imagine if there are 100,000 or 1 million wallets today in Ethereum, only 10,000 nodes. Now if I start increasing the nodes and I have to map it one by one, then in the end, if you would realize, it's not just because Vitalik said it a few days ago that in 2030 we would be doing transactions using our mobile wallets every 12 seconds or so. No, it is because if you continue to decentralize this way, which we started from one device to multi device to centralized system, centralized to today's semi decentralized systems, if you would continue to decentralize it that way, everybody will have a device, and everybody will be having that device, and that device will become a node of its own and would be capable of doing transactions directly. And in one sense you can say communicate to the other devices directly, because when you do a transaction you publish some information. That information is useful to another device somewhere else, or some other device needs to validate it. Then you're creating a network of peer devices which are directly doing all this, rather than some centralized 8,000, 10,000 nodes. This is where the evolution would go back. The peer to peer where we started, we are actually going there again. This is my opinion. This is not something which I believe is completely right from anybody else's perspective, but my own perspective, I believe this is what it should be, and this is what it will be in future. We'll again go back to the same uh, you know evolution quadrant where everything started, the pure peer to peer computing. And decentralization, when done enough, would actually take us to the point. I think you'll have several many curious thoughts coming onto this. We'll maybe talk about this, during the question answers. Do put those questions in the chat, interesting ones specifically, if you've got not just questions, ideas, opinions as well. Now let's talk about what is Web3. The typical structured way. I kind of mentioned it in my own version, but let's take a look at how it is by the book, by the thoughts, by the innovation, by the existence of systems today. So it can be seen as 3.0 because we see that it's the third iteration of the internet, the third version of internet. uh, and yes, that is right from the the third quadrant which I've spoken of: peer to peer, centralized, semi decentralized. So we are here right now. It's of course peer to peer. That's the end of it in terms of where the end game exists, where everybody would wants to be. And there is emphasis, like I said already, emphasis not enough today but would be more than enough tomorrow towards decentralizing it. And then uh, there are a lot of blockchain based technologies which are coming around, and the reason is of course because it exists and it has meaningful nature in terms of providing what we need out of it. And then it's a ubiquitous and it's semantic web. This is by the definition, and a lot of money has gone into it. These numbers are old. I would say we are looking at trillions in incoming years. This is just what happened in India. Some of the applications, because you guys are builders, you have done it all, and already you would know what these applications are: DAOs, NFTs, DeFi, crypto, finance domain having KYC, a lot of stuff. Gaming got famous. Asset management took up when NFT kind of happened in 2019 and all. So these are well known. I would not talk about them much. We'll simply go back to the basics of how do you do on anything at all. For example, when cloud first come in, people have no clue. They had no clue about how to set it up, how to configure a machine and all. I still remember my old good old days when we used to struggle in installing Linux as an operating system in our machines. Sometimes drivers were missing, instructions were not available, tutorials were not enough, and the process was like so lengthy and so complex that we used to shy away from using it as an operating system until some geek status, swag status got attached to it. Oh, I'm running Linux in my machine. I'm talking early 2000s. I'm not talking today. You guys do not even have to do that, right? Everything is so simple. You click, and your operating system is ready. You want a machine, you go to Amazon, Google Cloud, you get credits, you set it up in no time. So time is a different animal altogether. It changes things, and for good reasons. So we have seen that all. If I would ask any of you today that, dude, why don't you go out there and set up your own data center, you would point 10 fingers at me and tell me that you're so old school. Why would I do that? Why would I buy a server, a rack, set up a room, pay rent for it, set up a 24/7 team for maintaining this, remove the hard drives, configure it and all? I would simply go to AWS and GCP and do it. So you see, we are talking about challenges here. There were challenges in the infrastructure in the past, and there are challenges in the infrastructure today. It is just the type of the challenge has changed because of the technology on which the infrastructure is to be set upon. So we'll talk about those challenges here. When you set up Web3 infrastructure, I'll talk, from both the perspectives: permission protocols and permissionless protocols. Permissioned, of course, including Hyperledger. How can we miss that? And R3 Coda, Polygon Edge have launched Subnet. These are, the new generation of, you can say, some of them are hybrid blockchains, or you can say the new generation of private blockchains or permission blockchains. I'm talking about subnets in Avalanche and the Polygon Edge specifically. But yeah, Hyperledger Fabric and Coda, they have been the veterans. So decentralization is missing in the infrastructure. How infrastructure is related to decentralization? The question is very fundamental. The question is that if I'm setting up all the nodes owned by one party, is it decentralized? No, one party owns it. When I say one party owns the infrastructure, I mean maybe the machines are owned by him, but the access is with me, but still it's not decentralized. Imagine if I'm running it with two parties, but again in the same data center, then the data center is owned by someone else. So again, decentralization is not enough. Now, what we seek in terms of infrastructure decentralization, we see the ownership of the hardware should be distributed geographically as well, you know, control wise. So I don't want Jeff Bezos to control all my nodes. That's not decentralized, even though he says I would distribute it across all my data centers around the globe. I would still not agree that this is enough decentralized for me. But then I would do that. Oh, Sundar Pichai, you take some. Bezos, you take some. Nadella, you take some nodes of mine. Run them in your own clouds, and I would be slightly happier than I was running them in just one cloud. Then I would want some individuals to come in, some smaller data centers to come in, some smaller cloud players to come in, and then allow me to deploy my nodes. So you see, infrastructure decentralization or infrastructure level decentralization primarily means that you are not just distributing the nodes across geographies, but you're also distributing the ownership of those machines or hardwares upon which it is running, so that you don't have typical challenges of people controlling, becoming adversaries, influencing the network, or challenging it in some way or other, or tampering it, or trying to attack it. So this is the decentralization aspect, why it is missing and why it is becoming a challenge nowadays. Because enterprises, specifically enterprises, I'm quoting it again, they're very accustomed to run it in their clouds and their own premises machines, and they're not pretty comfortable with the concept of decentralization. I'm saying comfortable because they have even if they know, they have compliances and security and infosec teams of theirs, the so-called experts of security in enterprises, punching their face every other day, telling them that you're doing it wrong if you're running the node somewhere else. So you see, the challenge is within, and it's a real challenge. Second is time to market. Imagine I'm setting up a Hyperledger Fabric network in an enterprise setting for the production grade 99.999% uptime, and with all the compliance and security checks in place. And when I'm saying compliance and security checks, if you know the Bible of enterprises around it, it never ends. It's this big. There are pages and pages and pages and pages of guidelines which you need to follow. It means for a new technology like blockchain, and you're setting up a network as complex as R3 Coda or Hyperledger Fabric or Polygon Edge, you're going to take weeks and weeks and weeks of time until you get to that point where you say like, oh, my network is finally there. And I haven't seen a team yet which says with confidence that, oh, I deployed this network, I took like 4 weeks, tested it pretty well and all, and I can guarantee that this would function. I haven't seen a team like that yet, because they know anything can go wrong any day. This increases their time to market. The it's not the development of the project, it's like taking it to production, launching it. Developer machines, your laptops would not run it. They're going to be the real servers, real configurations of firewalls, VPCs, block uh, block volume encryptions, and a lot which needs to take place to take it to the production level. Hence, you're kind of increasing your time to market, and of course increasing the cost of setup and ownership. So these are real challenges which I'm talking here out of what we have worked with in the past and has seen in the past, taking use cases to production. Now, complexity of scaling is a different beast in itself. Imagine if BMW as a manufacturer has set up a Hyperledger Fabric based network, but now they would want more parties to come on board. The challenge is the other party may have a different cloud partnership, or they may not even have a tech team. It's just a simple supplier of some parts, manufacturing company. They don't even have tech teams, they don't even have DevOps, let alone the blockchain level DevOps expertise. Now, it's complex to scale. Even if they agree to hire some, then you're kind of dealing with a lot of cryptographic artifacts going here and there, and all the configuration happening there, being tested, saying done or not, and all kind of scenarios. You're dealing with all that. So that's a challenge as well as a problem to take upon. And then I kind of explained it in a simple way already by while we were discussing all these points, that it's complex to understand and adopt. Not everybody just can wake up every another morning and say like, oh, I know Web3. Let me know what you want to get done. I'll get done in by the evening. So it's complex and similarly challenging. Lack of know-how and expertise, reason is obvious. Lack of standard security and optimization, this is important. I think we can spend another minute here. If you would ask me, what is the HIPAA compliance, what is ISO 27001, I can give you books, I can give you material, you can find it on internet. There are agencies working for these things, ensuring that the infrastructure, the hardware, the machine, the software, the security of it is up to a point and compliant for certain guidelines. But there is nothing like that in Web3. IEEE is still busy researching and trying to standardize it, trying to form up standards. A lot of them have been done, still being improved. A lot of them are yet to come, still being worked upon. So this area is pretty much, an open window. So you got to work with each enterprise every time to figure out what their infosec needs are, and how do you reach or make them reach these standards, of security and performance and compliances. So you got to work with each enterprise in their own specific language, and then it would happen. And then you have to repeat the same with another enterprise, and then another enterprise, and then another enterprise, and there is no end to it. Now, all this together sounds like a lot of challenge, a lot of problem. But how do we solve it? So we solve it by bringing automation. Now there are reasons and plethora of reasons why automation have been given a preference upon manual implementations, human prone approaches. And we don't have to explore that in depth, but just focus upon the importance of it in Web3, the kind of usage it has in Web3. So we'll get to the point now. Cutting to the chase, Web3 is of course very wide. We just cannot put everything under one umbrella and say like this is done. So we need to see it from the perspective of businesses and the users. Users may include you and others as developers as well. Now, businesses, like we discussed in some of the challenges, they require a more sophisticated approach from the automation to ensure the things are in control, scale when they need to scale, always monitored, generating the proper production uptime, and then can be debugged and traced and do a lot of stuff upon it. So they have their own management expectation out of infrastructure automation. But if you come down to developers and people like hackers like you who want to build faster, you've got your own expectations. Reason is pretty much same. You don't want to repeat your node setup exercise every other day because you've done that once, you know that already, you've learned it enough. Now you just simply do not want to waste your time doing that again and again and again every other day. When you set up a new project or build something new, you simply want to focus upon building that new stuff in that innovative app which you have in mind, rather than investing 10, 20, 30% of your time in setting up the infra, first in your machine, then on your cloud, and then launching it and then testing it and then ensuring that it works fine. So it has different meanings for different kind of consumers or users or participants. Now, one thing above all which we can't underestimate is the cost, gentlemen, because this is a very detailed infographic, but I'll simply point you out one thing which we usually underestimate. It might offend some of you, but this is the harsh reality of the ecosystem today. I'm a techie, and I cannot let go of a feeling that there is something which I cannot do. So I keep telling myself that, Gun, even if Web3, you can learn it fine, and nobody can tell you that you gotta use this or that to do your thing, because you can do it. You're a smart person, and that's my mistake. And the example is, I think one colleague of mine in one of the meetups in Dehradun told this example, and I really liked it. Just because we still have old ways of doing things, we continue to resist on the new things. For example, why we book a cab today? We still have old ways. We can go out on the road, we can stop autos and cabs manually, like people have done it in the past. But we prefer apps because we believe they're faster, they're more optimized, they save us time, they give us control, they give us more accuracy. So we use apps. But and same way, I gave an example of cloud. We don't set up data centers at all. We don't invest our time, the other money, and then bring in the complexity of maintaining it. But we go to AWS, GCP, Azure, and other clouds. Same way, when people set up blockchain nodes or create networks, they think that the expertise is in house, and they put engineers at task. The developers whose job, or who are supposed to develop the projects beautifully in better ways, they put them to do the task to set up machines and set up nodes, secure them, and create endpoints, track them, debug them every time they go down and all, which is the wrong practice. And this is why, if you see the third line from the top, ongoing maintenance cost, it is consistent regardless of it is year 1, 2, 3, 4, 5. It's not decreasing, because it's a consistent cost of maintaining infrastructure. Be it any service running on any machine, it takes a consistent effort. And that's something we need to digest and understand to the bones and to the veins, that it's not everything we should be doing just because we know it. We should rely upon tools. For example, when I learned virtual environments or containerization, it was way before then Docker and Kubernetes existed. I learned it through CH routing and all. We used to create, multiple file systems inside the machine on the Linux operating system. Some of you may know it, some of you may not heard of it at all, CH root. But then today I don't do it anymore because I know I'm wasting my time. There is Docker available, there is Kubernetes available, there is Podman available. Why would I do the same? So that's one learning we have got, that if you know how to do it, does not mean you have to do it. So if there are tools, utilize them. If there are platforms, leverage them. If there are frameworks, invest your time in utilizing their benefits and build faster. And don't invest neither money nor your time into maintaining the infrastructure, specifically the Web3 infrastructure of the date, which is consistently upgrading. One example is, if I would set up one Ethereum node myself, Ethereum, let alone Ethereum, let's set up Polygon. Every month it has got pruning requirement, it has got patches available. So should I be investing my time in doing so, or should I be building my app and coding in, uh, coding towards, releasing it faster and faster, fixing bugs? That's the choice. And that's why maintenance of the infrastructure, Web3 infrastructure, is a thing which you cannot underestimate. Now, what do we need to not just settle on those challenges and to tackle to the problem statements which I kind of accumulated in last two slides? So we need automation, that's certain now. But what this automation is supposed to do? So of course, it should allow me to set up protocols. It should allow me to configure them my own way. For example, if I'm doing Hyperledger Fabric, I want to choose the version of it. I want to choose the consensus out of it. Of course, in 2.x, you don't have choice of consensus, it is draft only. But then beyond that, I need to choose the topology I'm trying to create. How many orderers, how many peers? Do I want a persistent storage, or it's a pilot, I want to save cost here? Or, uh, you know, what kind of data centers or which cloud I would want to choose and deploy it upon. So you need a lot of flexibility, which is this automation is supposed to provide. And then once deployed and configured, you want it in a low code approach, because again, we're trying to reduce the complexity of you doing it all over and all over again for different projects every other time you build them and run them and launch them. So it should be a low code approach, or maybe in fact a no code approach, where you click a few buttons like you do on Amazon, and it happens. And then it should give you enough choices. It's the same conversation we started with, that it should not limit you to one cloud, the other cloud, the third cloud. I know Amazon has a blockchain service, but then they won't allow you to deploy nodes on Google Cloud. They won't allow you to deploy node on DigitalOcean. I see that's a centralized service has got no use of. So you prefer an automation which allow you, uh, you know, multiple infrastructure elements supported at the back, including all the major clouds, and in fact, if required, on-premise as well. And then by doing so, you allow every stakeholder in the consortium to have their own choices, have their own decisions, and yet participate in the same network. What more you expect out of such an automation? You want a cut above security practice, standardization across all the deployments you do. So regardless of I'm doing Fabric, Coda, Ethereum, or Polygon, I must ensure, I'm just giving some examples here, not covering it all in one line. I must ensure that the practice of securing the network ingress, egress, the ports, if open or not, and all the volume encryption and all, these practices are standard. They must be across the protocols. So your automation should cater to different needs of the protocol, of course, specific needs of the protocol, of course, but then have a general layer which ensures at least these 30, 40, 50, 100 points and are there in green ticks every time you deploy or set up something. And then it's not just about setting it up and configuring it, because it may be one time or two time or 10 time, because you're not going to be doing like 100 projects in 1 year. You're going to be maybe 1 to 10 projects in a year, if they're that scale. But you require consistent monitoring analytics, in fact proactive monitoring. Why not have proactive monitoring? So you would want proper alerts, notifications, all the right data captured, not just around CPU, RAMs, disk, and IO and networking data. You also want blockchain level data like transaction latencies, throughput of your application, current throughput, in fact, number of transactions per second it's doing, the delays, the block height, syncing issues, and all. And you want everything captured, and then you want alerts and notifications, and specifically in a decentralized setting where not just one party owns it all, multiple parties owns it jointly. So you want an automation to kind of facilitate all this as well, so that you can recover from incidents faster, you can know before it happens, you can act when it is needed to be acted upon. And then in the end, you don't want cost to shut your project down. So cost is one kind of a challenge. Strategic decisions are another kind of challenge. But we have seen that more often. The recent failures, I'll quote one of them or two of them. V.Trade, TradeLens was one of the most famous trade finance ecosystem created by Maersk and IBM, but they could not bring in the collaboration. Reasons were multiple. Strategic priorities were different for those other collaborators, stakeholders. They didn't have the enough technological understanding or awareness. Even they could not bear the cost of running the nodes and machines and all, because it was too expensive, and they didn't have ROI. So they kind of decided to shut it down. It happened just like pretty recently, if you want to Google about it. And then Trade, another trade finance ecosystem use case, gone down the same path. So yeah, controlling the cost is pretty important, while specifically scaling your consortiums and optimizing it. So you need an automation which can downscale, upscale. Do not want you to put like a 24/7 team while it can monitor it automatically. Example is, do you have people managing clouds 24/7 because you rely upon their monitoring of the machines? So you need Web3 automations to also cater to your Web3 services and nodes the same way, and APIs the same way. Now, what we do at Zeeve is exactly trying to solve all what we've just talked about. We we are trying to save you more than 60% of the cost, 90% of the time, in terms of how do you set up nodes, RPC endpoints, or consortium networks across multiple clouds. You can connect your own cloud accounts. You can take it like completely Zeeve managed as well. We got like a lot of Fortune 500 companies using Zeeve as of now, including Vodafone, Temasek, MarketNode, Intel, uh, GateNet, and then more than 15,000 developers, trying to build a lot of newer blockchain Web3 apps using Zeeve, either by running a node, a network, or directly consuming our API endpoints, Elastic APIs. Now, what it provides you looks like this. So what you see here is the topology of a fabric network where CAs, orders, peers are running on, you know, AWS cloud, AP South data center, and then you see the visual topology. I think Zeeve is the only platform where you can see your network. You can see its topology, you can see it growing, you can see the life status of it, you can control and who runs and when. You can you can see a lot of Kubernetes level monitoring stuff. You can see a lot of machine level monitoring stuff. You can see a lot of order peer CA service level monitoring stuff. And if it is permissionless blockchains and you're consuming APIs, you can see the API metrics, like how many HTTP endpoints you have hit, how many WebSocket endpoints you have hit, what methods you have hit, how many have failed, why failed. So it helps you debug faster and get in control of your outcomes. Now, benefits of Web3 automation. Ultimately, all this which we've been building or has been built out there in the market towards optimizing and automating the Web3 infrastructure is for some real substantial purpose. We will be iterating some of the facts which we discussed already, but I would simply take you through those from a different perspective again. So we have to run the networks and nodes and to get the API endpoints or to the SDKs to function with those networks, or to make the use cases happen, right? It's like if you need to run the car, you need the fuel, right? It's inevitable, it's inexorable, it's something you cannot dodge, it's something you cannot avoid. So you need to have the Web3 infrastructure in place. Why not reduce the cost, increase the manageability and sustainability by using automation? It's as simple as that. Electric cars were bound to happen. We just delayed them big time because we did not believe in them. So if automations exist, use them. Do not always dig the same hole because you know how to dig it. Second, decrease the time to market. Competition is pretty high. If you have an idea in mind, better build it faster, launch it faster. Do not waste your time. And I'm giving you, facts. 30% of engineers' time in Web3 space is getting invested into infrastructure development and maintenance and setup, which should not be done. If you're investing your time like that, stop doing it. Get onto an automation project. Then standard practices. I could not talk enough on this in terms of how much it is important and emphasized upon, or is to be emphasized upon, because we have seen with enterprise use cases, if you're building something for future of supply chain or trade finance or banking or fintech ecosystem or gaming ecosystem, you would go through, or maybe a healthcare ecosystem, you would go through a lot of challenges if you won't follow automation, because humans are error prone. Then they forget, of course, and then they won't repeat the same thing the same way 10 times, but automation would do. And then there are a lot of things to be done, and it would always consume your time, your cost, your energy, and make you more error prone if you do it manually. And then there are regular updates, patches, rollouts are happening in these technologies because it's new and you have to worry about it. For example, if you last month, if Tron has released an update that if you would not have updated your node by 17th of January, you would have been not functional in the network anymore. Now who cares for that while you're busy building in your Visual Studio Code or other IDs, or you have launched your application? Would you want to consistently be consumed by your past which you have built and launched, or you would want to build newer and newer application and maintain them as well? So regular updates and patch, these are the things which you don't want to worry and get benefited by the capabilities of an automation for you. And then scaling, setting up network consortiums, and making non-technical consortium stakeholders or network participants to adopt Web3 easily by letting them utilize an automation, rather than doing it the orthodox way and always feeling more troubled or feeling that they cannot defeat the complexity and move away from the technology and shy away from it. uh, so I think these are certain benefits which you can achieve if you are going to use automation. And of course, Zeeve does it all. I would encourage you to sign up and maybe check it yourself. You can find endpoints for uh, you know a lot of public protocols, 20 plus already. You find capabilities to automate Hyperledger Fabric. If you're some of you are building on Hyperledger Fabric R3 Coda, of course you can take free trials for 3 months to build your use case, test them and all, launch them, take them to the market too. If you're building on public endpoints, Infura, kind of services can be available on 20 plus protocols on Zeeve, be it substrate ecosystem, be it EVM ecosystem, be it Solana, Algorand, and others. And we are present everywhere. You can get in touch with us anytime you would want. So I think this is where I'll take a pause. This is pretty much the completion of the topic as such, the automation, its importance, why it is needed, what we provide, how you can leverage it, and then of course get the free credits to yourself. So do reach out to us, sign up on Zeeve, and get the free credits so that you can build faster and better. I think I'll open the session now up for the questions, and we'll take them.
All right, thank you so much. So we do have actually one question in the chat. So Manan asks, how does it ensure decentralization and security while also providing cost control and scalable analytics and monitoring?
Right. So I'll give you some interesting thoughts about it. In fact, I'll give you a real simulation of how it happens. For example, if I'm creating a Hyperledger Fabric network for a customer of ours, now they have their own cloud as a preference. So what Zeeve does is it commissions the nodes, the orderers, peers, the CAs into their own cloud, and so we don't own the nodes in this way. This is a bring your own cloud model, so they run the nodes in their own cloud. When that happens, the monitoring which we do into their browsers, it directly the browser app which they open up as a dashboard, as a monitoring panel for them, it directly feeds upon the node they're running. So it does not relay or route through the Zeeve in this case. It directly communicates through the node. Even the RPC endpoints, if you're creating and consuming using a dedicated node through Zeeve, so you can set up Polygon node, Ethereum node, Binance node, or Avalanche node, or Polkadot node in your own cloud accounts. And when that runs there, when you consume it in your app, you directly talk to the node. You don't go and relay through Zeeve. So we don't have a relay wrapper like some of the providers out there. So we go down, you don't go down. So it's like if you're using Infura, Infura goes down tomorrow, your dApp goes down tomorrow with it. But with Zeeve, if you're running a dedicated node, consuming it, we go down, you don't go down with it. So that's how we are ensuring that decentralization exists with the optimization and cost control and scalable analytics and monitoring along with it.
Awesome. Thank you so much. I hope that clears your doubt, Manan. Next, I have, if some students want to enter Web 3.0 and they don't have any knowledge regarding it, how should they go ahead? I think that's what he means.
Yeah, it's the team noob entity, if I remember right. The
Yeah,
noob,
yes.
they're not noob, of course. I know that for sure. But this question, of course, is pretty interesting in terms of how individuals can learn. So there's a lot of material on the internet, and we are all accustomed nowadays, very comfortable in reading over the internet on technology aspects, specifically being students nowadays. But then Web3 is a technology where there is no structured approach available. You would read this here, that here, and those facts there, and these facts somewhere else, and somebody would come up someday running his own blog telling you that I would teach you blockchain in 10 different series of mine and 5 different minutes. But there is no structured way. So I think you must focus on finding a structured way. The best way is to read books. I started by reading the famous book on Bitcoin itself. And initially you would need structure, and then once you mature as an individual into it, then you can actually understand what material is better suits you, or works for you, and which way to go for. And of course, don't go like 10 protocols at the same time. Pick your target. If you want to focus on permission blockchain protocols, pick Fabric or Coda one at a time, understand it, then move to others, so that would see the nuances, the differences, the comparisons, the benefits as well. And if you are going permissionless route, of course, start with the protocols which are most convenient. The material is available pretty easily on them, like Ethereum, of course, or other EVMs. And then also go one by one. Try to start with Ethereum, try to go about the substrate framework as well, Cosmos as well, so that you don't miss. Because Web3 is all about understanding all the perspectives, not creating just one perspective and run upon it.
Mhm.
Pratham
Understandable.
Savali asking, yeah,
Yes.
machine learning
This
plus
is
Web3
interesting.
equals to chat GPT, a decentralized chat GPT, I would tell you that. So this is interesting. I would share my one of my own learnings. So I spent a lot of time in 2021 working with Intel on a decentralized machine learning project. So we were, us and Zeeve and Intel, we were like, co-ideating on it. How do we create it and all. The basic goal is, I would tell you the challenge with AI and ML today. If you would tell me that you want, research upon cancer, then you would say that I need all the data in the world to come to the best results, because I would want to train my model on top of all the data. This much data is not enough, this much is not enough, this much is not enough, this much is not enough. I want all the data. Then I'll get best results out of it. If you go out there, talk to Toshiba, because they manufacture PAT scan machines. You talk to Siemens, they manufacture PAT scans, MRIs, CT scan machines. Nobody would give you all the data. They would say, like, if you're talking to a competitor, we would not give you. So you cannot sign contracts with all the manufacturing companies. One, then you cannot go to all the pharmaceutical companies, all the research institute, all the hospitals, get them give you all the case studies. Impossible. They would never do so. So machine learning and AI, they never work best if you don't have all the data. And in this world now, it's impossible in any segment of industry to get all the data at one place and then train your model upon it. So we with Intel worked upon this decentralized machine learning project, where data was never supposed to travel. The parameters, the weights are supposed to travel every time. This
Yeah.
way, you're anonymizing. You don't have to anonymize data, because data always sits with the owner. And models do iterations, and then federated aggregated average of them makes them more mature, and then they trained again and then again, and this continues. So machine learning plus Web3 is a very interesting future towards getting right, accurate intelligence available to us.
Hmm. Makes sense. Does definitely does make sense. So Manan asks another question: how does it allow the flexibility to choose between cloud or on-premise infrastructure for consortium members? Can you just brief about that?
So how does it allow the flexibility to choose between cloud and on-premise infrastructure? So I'll give you the reality check. So we got some customers, some banks as a customers. For example, DCB Bank is our customer. It's one of the regional banks in India. And Prasanna Lohar, if you know, he's one of the most interesting influencers, most known influencers in the community. So they always, banks always prefer on-premise infrastructure for their own compliance and security reasons. But then now fintech world is also moving to clouds in some way or other. So you don't get to choose it. It's the people who are participating in the use case, they get to choose it. Now the
Hmm.
job of the automation is to ensure that when they choose, for example, it's a 5 bank consortium, two of them are running on clouds, one on AWS, one on GCP. One of them is on-premise, two of them are running their own private data centers but owned by another third party. Then you want automation to kind of allow them to deploy their nodes on all of them, and then connect with each other, and then get the control, monitoring, analytics of them themselves within what they control or own in the network. But you never get to choose. It's the members who get to choose. And of course, this choice is not driven by the nature of technology, or limited by the available options in infrastructure. It's mostly driven as of today by the compliance and infosec requirements of their own teams or security people inside.
Right. I hope that answers your question, Manan. Thank you for asking. So Green Planet has another question. Is it good for going directly to learn Web3, or should I search other fields by your point of view for new people, new students?
They are not noob. Nobody is noob, in fact. The reason being, if you're asking this question, you already know, that Web3 is a term, and you can Google about it. So you, there is a difference between learning Web3, because the difference lies in perspective. For example, I see it from, I've given you my perspective about how I see the network evolving and all. So if you go by that take, you need more of computer networks, understanding of networking. You need more understanding about the principle of networking. You need more understanding about how web works, how telecom functions work, which provides us internet. Because people, of course, even in our conversation, we talked about that, oh, clouds are going to centralize it, so we distribute the nodes and machines and all. But nobody talks about that we still run our internet through Airtel, Vodafone, and other providers. Can we skip them? So telecom is still another pillar alongside the cloud. So machines, which are the hardware on upon which we run the node, and then the internet provider through which we connect to the nodes, both are the centralized providers. So of course, you need to learn a lot about the legacy technology in this sense, so that you understand what decentralization really means, how it happens. And then there is another perspective, which is programming side of it, which would not reveal you the real vision behind Web3, the decentralization, the beauty of it and all, but would allow you to program. So you can start programming by learning typical languages like Node.js, Python, because there are SDKs available. So this is the easiest way to get in and then get your hands up on it. But then sooner or later, I would advise, and I advise everybody about it, that don't just focus on programming. See the bigger picture. Try to understand the fundamentals of the technology. Try to understand it from the perspective of what what ancillary technologies or tools are being built around it, and how they contribute, what is the impact. So learn Web3 as a theory from internet. Learn programming languages from different platforms available, or through books or through your institutions. But then try to connect the dots using both of them in the bigger picture, where you would understand it from the cloud perspective, from the telecom provider perspective, from the decentralization perspective. And in fact, like this question came up, machine learning plus Web3 perspective as well, because these are all perspectives. I'm sharing perspectives here. I'm not stating anything which is very state, written in gold, never can change. So yeah, learn the way you would like, but learn for the bigger picture.
All right. Thank you so much, Planet, for asking that. And do we have any more questions? I think
I
not.
think we need to debug that emoji, hand purple blue piece.
Yes, hand purple,
That's
blue piece. Is it the
for everyone.
purple? The hand is purple or hand is blue and purple? Oh, what? Okay, yes, we do need to debug that. Probably
Yeah.
need to build something around it. Yeah. All right. So, thank you so much, Khan, once again for coming today. And let me see. I think yeah, of course, everybody is saying thank you so much for the answers. You cleared their confusions. It was very insightful. So I am not speaking your audiences. And once again, thank you so much, everyone, for joining us today. And I will say bye to Ghan now and have a great day ahead.
Yeah. Thank you,
Bye
Pooja,
bye.
for hosting us. And I think Green Planet, cloud or Web3, you don't have to make a choice, because sooner or later Web3 will become the new cloud. So
Yes, of course.
bye bye.
Awesome. So, for the folks who are here, this was just the first part of our very exciting 5 part workshop series. Tomorrow, at the same time, we will be having Mr. Kshitij Agarwal talking about design sense for developers, which is going to be a very insightful sessions for folks from all kinds of levels, beginner, intermediate, and advanced. For all updates and notifications, join our Discord, discord.hackthisfall.tech. You can see it right on your screens right now. And once again, thank you so much for joining. Have a great, positive, and productive day ahead. Thank you.